Assalamu alaikum and good evening to one and all. Welcome back to Chemical Bounding, and I'm glad that not all of you but few of you have attempted the online assessment test, and most of you could do it very well. That shows that you have understood the concept, but I had to give you a little feedback which has been given individually. Please go through it, and I hope that the next part of it will be covered. And Sumaya was having some interesting questions. So Sumaya, I hope now this session would clarify your doubts. Still, if you have any doubts, please feel free to post it to me. So let's start again. As you all know that there is some reason behind placing all these elements into a particular group of a period based upon their properties. And then we came to something called bonding, chemical bonding, and the types of bonding. So as we all know that sodium and chlorine are oppositely charged, and it's a strong ionic bond. So when we try to, and Sumaya's question was about the octet rule. Yes, octet rule is the inert gas rules where the outermost shell, if I can share a pen with you, with a pen, I'll just show you how it is. Yeah. See, this is the outermost shell, okay? So this outermost shell has got one electron in it. And then the other, this shell has got 8 electrons, right? And then innermost will have, S will always have 2. So 2, 8 and 1. So the outermost shell, which we call it as a valence shell, has got 1 electron in it. So what happens if sodium has to get an octet rule or to become stable, either sodium should gain 7 electrons to become octet or lose 1 electron. If it loses its one outermost electron, then its outermost shell will have 8 electrons and it will become stable. So what will sodium do in this position? It will not try to gain 7 electrons, because losing 1 electron is easier than gaining 7 electrons. So it will lose that electron and may become stable. Or else, so it will just remain as Na without any positive or negative charge on it. Whereas chlorine has got, if you look at the chlorine's outermost shell, it has got 1, 2, 3, 4, 5, 6, 7. It has got 7 electrons. So chlorine definitely would not like to lose all its 7 electrons from the outermost shell. To get an octet rule, follow that and to become stable, it will try to gain 1 electron. So that is how here sodium is ready to, donate its electron, and chlorine is ready to accept. So that is how it is losing, it is gaining, and both of them are forming a strong covalent, strong ionic bond. So that is how the elements share, lose, and gain electrons in order to become stable. And yeah. So hope this is clear, and I could clear your doubts, Maya. If you have, it's not clear, please go through it and come back again. Now, next is we're going to talk about so you see that they are allowed to undergo change. So let us understand with this the following. If you look at group 1A elements, that is lithium, sodium, potassium, rubidium, cesium, and francium are the elements that are present in 1A. And what are the properties of all these elements? As I told you, that these elements are placed in one either group or period based upon their properties. So they are ready to lose. these are the elements, 1A element. This was what I was asking a question yesterday in your test also. Which are that lose electrons that are ready to lose their electrons are 1A group. Because to get an octet rule, they are ready to lose their outermost electron. Just now we have seen for sodium. So is the case with lithium, potassium, rubidium, and CS also. Please learn these formula symbols. These symbols represent an element. So now they try to lose one valence shell electron from their atoms and unipositive ion which gets octet in their outermost shell. So that once if they lose one electron which is there in their outermost shell, the other inner shell which is having 8 electrons, it can attain that octet rule. As we were saying that the octet rule is a standard one where every element would like to become stable by attaining octet rule. But there are certain exceptional elements which are not happy with octet rule also. So we'll come to know about them as we move further. So let's look at this example. In this example, you see that sodium is written, the configuration is written as 2, 8, and 1. So the innermost shell has got 2 electrons. Okay. So then it has got 8 and it's ready to lose 1 electron. Similarly, if you come to group 2, the elements that is magnesium, barium, they try to lose 2 valence. They have got 2 electrons in their outermost shell and they are called as the dipositive ions. If they have got one, unipositive, dipositive, if only 1 electron is there which they are ready to lose, then they are called as unipositive. Whereas group 2 elements are dipositive because they have got 2 electrons in their outermost shell which they are ready to share them to get an octet rule. To become stable. Then what happens in group 3 is again explained. I'll just show you the pictorial way how is this octet rule applied. So if you look at magnesium carefully, you see that what exactly is happening here. So in magnesium, you can see that there are total 12 electrons, right? You start counting. इसके अंदर वाले shell में you have got right from the nucleus, you find this S orbit has got 2 electrons, okay? Then P has got 1, 2, 3, 4, 5, 6, 7, 8. So this 8 is an octet. If 8 are present, that means it's stable. This second shell is a stable shell. But the outermost shell has got 2 electrons, which are not stable. Either they should gain 6 electrons, magnesium should gain 6 electrons to become stable, or it should lose 2 electrons. So always losing 2 electrons is easier than gaining 6 electrons. So that is how you see the configuration of magnesium as this 2, 8, and 2. When it is 2, 8, and 2, you should understand that it has got innermost is 2, then 8, then 2 in the outermost shell. So this is how it's arranged. And because 2 plus is given because it has got 2 diatomic. Okay. Then group 3 has got 3 electrons in its outermost shell. So corresponding to tripositive. Now they become tripositive. You can see the example of aluminium. Aluminium has got 2, 8, and 3. So now even the third group elements are also ready to lose these tripositive ones also. And their valency is 3. Now if you come to 6A, they try to gain 2 electrons into the valence shells of their atom during the chemical changes and form corresponding di-negative, which gets octet in their outermost shell. So you have seen that as long as it is 1, 2, or 3, they want to lose. But once you look into oxygen atom, oxygen has got 1, 2, 3, 4, 5, 6. It has got 6 electrons in its outermost shell. So definitely it will not lose 6 electrons. Instead, it will try to gain 2 electrons to form an octet. So it becomes 2 negative. And in 7th A, also you see that they'll naturally try to. So as they're moving from 1 to 7 towards the right side, you see that the tendency of gaining electrons increases to form an octet rule in their outermost shell. They want to gain electrons. And as you move from right to left, the tendency of losing of electrons increases, right? And if you look at 8A electron, which we call it as the noble gases, they try to lose nor gain. Generally, if you see helium and neon, they do not participate in any chemical change because they are very stable. They have got 8 electrons in their outermost shell. So even other electrons like 8A do not gain, and when they participate in a very few chemical changes, but they do participate in the chemical changes and on very few instances, as I told you, when it is required. Like if you look at neon, no electron gain or loss takes place. It is stable in itself. That's the reason you won't find any charge over it, neither positively charged nor negatively charged, where they are stable. Okay. Now let us see what happens to these noble gases. When they have 8 electrons in the valence shells in their atoms, what exactly is happening in helium? In helium, you see that there are 2 electrons, but its only shell is completely filled because the innermost shell is filled only with 2 electrons. So it's filled. That is the reason it has been kept into neither. It is also stable and does not take part in any reaction. And therefore, it is concluded that any species with 8 electrons in the valence shell is stable. But helium is the only one electron where its outermost shell with 2 electrons is also stable, and it doesn't want to take part. That is the reason it's kept in the series here. You see the noble gases series, helium. Others are all having neon, argon, krypton, xenon, and rhenon are having 8 electrons in their outermost shell. The 8 electrons definitely gives stability to the ion or an atom. So that is how we see how this octet rule is formed. It's formed, in sodium chloride. So let us see what happens in sodium chloride. As I told you, Lewis and Purcell, they provided a logical explanation about the valency on the basis of lack of chemical activity in the noble gases. As I told you, noble gases are very inactive, and it may be stated atoms or electrons, they undergo chemical changes that helps to leave their atoms with 8 outer shell electrons into it. So you have clearly, you can see that there are the 8 outermost electrons that are revolving around, and neon is quite stable. It need not take part in any reaction to become stable. So it neither gains nor loses. So outermost shell can accommodate maximum not more than 8 electrons. Maximum capacity of the outermost shell is 8. Either now if it has to gain or it has to form a bond with any electron, it has to lose electrons, or it should get extra shell around it if it has to gain. Okay, so it will not remain neon anymore if it has to lose or gain. Now there are different types of Lewis and Purcell has explained about what do you mean by ionic bond and covalent bond. So it's very interesting when you see that electrostatic bond or the force of attraction is based upon the charges. If you see sodium and chlorine, they are oppositely charged. So this dissimilar oppositely charged attraction is responsible for this strong ionic bond. Whereas the highly reactive alkali metals, like you are seeing in first A, the The alkali metals that you see in first A, that is lithium, sodium, potassium, they are highly reactive. Why are they so reactive? Because of their outermost shell that has got one electron and they are ready to lose. And similarly, if you look at the fluorine, chlorine, bromine, iodine, even they are highly reactive, because to become stable, even they have to gain only one electron. So they are ready to gain one electron and they are ready to donate their electrons. So that's how when they come in contact with each other, they become highly reactive. So sodium is in first A, and in the seventh A we have got chlorine. That is the reason sodium and chlorine could form a very strong bond. Now, if you look at sodium, sodium is 2, 8, and 1, and it is positive. That means it is ready to lose its electron. And if you look at magnesium, magnesium is ready to lose its 2 electrons in its outermost shell. So, and aluminium is ready to lose its 3 electrons in its positive shell. So, we need to have an element that is ready to accept 3 and form an octet rule would be interested in joining with them. Okay, to attain 8 electrons in the outermost shell, non-metal atoms have to have 5, 5 or 7 valence electrons. It has to gain either 3, 2 or 1 electron respectively from negative ions known as anions. So if it is gaining electrons, it is called anions, and if it is losing, it is cations. So 2, 8, 8, if you look at the P shell of phosphorus, if you look at the phosphorus, it has got 2, 8 and 5. Okay, so 5 electrons are present in its outermost shell. So phosphorus would definitely like to gain electrons. It will not lose electrons. And sulfur has got 2, 8 and 6. So it is 2 minus. It wants to gain 2 electrons to form the octet rule. And chlorine has got 7 electrons in its outermost shell. So definitely not lose. It will gain 1 electron to form this octet rule. And if you know, the number of electrons lost from the metal atom is the valence of its element, which is equal to its group number. Even, Lewis and Mendeleev has very well made it very easy for us to understand. He has given the group number based on that. If sodium has got 1 electron, it's in group 1. Okay, and magnesium can lose 2, so it is placed in group 2. So based upon the number of electrons that they are ready to lose or gain, they are in that group. So example, the valency of chlorine is 1. And let us see how is this ionic bond of sodium and chloride, which is very strong, has been formed. If you see, sodium is a cation because it is positively charged, and chlorine is an anion because it is negatively charged. So the transfer, these are formed because of the transfer of electrons from each other, and they form their outermost shells are sharing electrons and forming an ionic bond. So this is called an ionic bond. So in this, what is happening? They are neither gaining or they are sharing electrons. Okay, they are neither donating and accepting, but they are sharing these electrons in their outermost shell. Their outermost shells are joining, forming a bond, and this type of bond is called as electrovalent bond because it is forming because of cations and anions. Thus, we define ionic bond as follows. This definition is very important. The electrostatic attractive force that keeps cations and anions together is called as ionic bond. So note this down, which are formed from metal atoms and non-metal atoms due to transfer of electrons together to form a new electrically neutral compound is called as an ionic bond. Now explain the formation of ionic bond in sodium chloride, magnesium chloride, sodium oxide and aluminum fluoride. If you go through Lewis electron dot symbol formula, which Sumaya wanted to know, why do we have dots on it? So now you will understand what does those dots denote. Okay, sodium and chloride is formed from an element, that is sodium is an element, chloride is an element, and now it has been explained like this. if you look at sodium, sodium is S. When it is written as S, this is very important. Whenever you see a chemical formula, uh, beside an element, if S is mentioned, that means it is in a solid state. Okay. If G is mentioned, that is that it is in a gaseous state. So what is happening in sodium chloride? Sodium plus half of the chlorine element, gaseous element, is combining to form sodium chloride, and sodium chloride is formed in a form of it is in solid state. So it can be explained as followed. If you can just see, this is how the formula is written. You will see that Na plus Cl gives NaCl, and when sodium gets electron, it forms a Na plus cation configuration, and neon atom, and the electronic configuration of that of neon is only Ne. We are not writing negative or positive to neon, because neon has got an octet rule, and that is what it is neither a cation nor an anion, whereas sodium is a cation. So if you look at this sodium gas, when it has gained one electron, and you can see the electronic configuration of it is 2, 8, and 1. Or if you look at neon, it is 3s1, because only one valence. So chlorine has got a shortage of one electron. As I told you, it has got 7 electrons in its outermost shell. It requires only one electron. So chlorine is placed in the 7th group, whereas argon is in 8th group, because argon is complete with all the electrons in its shell. So now you can understand how beautifully and thoughtfully Mendeleev has placed all these elements. So as soon as, if you remember the group number, and if you can remember the properties, so what happens to the elements as it is moving from left to right? So left to right, and what is happening when it is moving, if you are going from right to left. So go through the properties. So all these are so systematically kept into a periodic table. That is the reason understanding of the periodic table is very important. Please go through it again and again to understand the properties of these elements. Then the transfer of electrons between sodium and chlorine atoms depends upon the oppositely charged items that are being attracted by the electrostatic forces, and they form a compound called sodium chloride. So sodium chloride is, you can see that sodium plus chlorine, when they combine together, they form in a solid state, sodium chloride is formed. It's nothing but your salt, common salt, namak that you see in your kitchen, how it is formed. Now, what is magnesium chloride? You must have seen the milk of magnesium also, very commonly used. So magnesium chloride is formed from the elements. So similarly, magnesium and chlorine. We know that chlorine, magnesium has got 2 electrons in its outermost shell. So it requires 2 chlorine atoms, 2 elements to make magnesium chloride. So until and unless it has to share its electron with 2 chlorine atoms. That is the reason we write it as MgCl2, where chlorine is sharing its electron with the outermost shell of magnesium. So because magnesium has got 2 electrons, 2 chlorine items join with it, whereas sodium has got only 1. So it cannot accommodate more than 1 chlorine item. So you can see 2Cl minus, because it is an anion having 2 extra electrons, and its configuration is 287, and to form an octet rule, it has to gain or share an electron and become 288 like neon and argon. Okay, so that's all. Neon and argon are all called the octet or the noble gases, inert gases, inactive gases. All this is given because their outermost shell is complete. So magnesium is MgCl2. So magnesium has got a capacity to to attract 2 chlorines to form MgCl2 bound. So magnesium chloride is always MgCl2. One magnesium can have 2 chlorine items with it. And similarly, if we go to 3rd group, So how you can just see how this element. So every element doesn't have the capacity. Look at it, how nature has made. So every element cannot, like sodium doesn't have a capacity to combine with more than one, whereas magnesium has got the capacity to combine with more than one element because it has got two electrons in its outermost shell. So now let us see how this sodium, disodium monoxide formation, how is it happening, disodium. In disodium monoxide formation, we know that sodium has got only one outermost electron. So how it is becoming disodium? Supposing if these two are electrons are gaining, its configuration is 2, 8, and 1. So one has to either lose or gain, or they can share to form this octet group. So that is how we find that two electrons are there in their outermost. So that is how it has become dioxide. So two electrons in oxygen also, you see it oxygen requires two electrons to become stable. It has got 6 electrons in its outermost shell. So it has to combine to get 2 electrons. If it has to combine with sodium, it has to combine with disodium, not with one single sodium. So that is the reason you see that Na2O bound, when we call it sodium oxide bond is formed, it has to, 2 sodium atoms has to combine with oxygen to form a stable sodium oxide gas. And this sodium and oxygen, they both are in a gaseous form. When they combine, they change their state to solid. So sodium oxide is a solid form. You see that O2 minus, that means oxygen has a capacity to accept 2 electrons, and sodium has a capacity to give 1 electron to, so 2 sodiums can join with oxygen forming sodium oxide bond, and this is also one of the strong bonds. So you can just imagine how many electrons and how many compounds can be formed with these many electrons, and it can even combine with other, like how cations and anions in an ionic bond are existing in a solid state. How do they form a solid state? So let us see an example of sodium chloride. What happens? Do you think that sodium and chlorine as unit would be present in a solid crystal? A solid one crystal is enough to represent sodium chloride. If you think so, it's not correct. Remember, the electrostatic force are non-directional. Okay, so there is no direction to this electrostatic force of attraction. So therefore, it is not possible for one sodium to be attracted by one chlorine and vice versa. So depending upon the size and charges of the particular ion, number of oppositely charged ions gets attracted by it, and that is how it defines the number. The quantity of sodium chloride is defined, or a crystal that is formed by numerous sodiums and chlorines that join together. So here we see 6 chlorine atoms joining, forming this shape. So ionic compound in a crystalline state consists of orderly arranged cations and anions held together by electrostatic force of attraction in these dimensions. And you find the beautiful shapes of these crystals that are formed because of this. This crystal structure of sodium chloride is seen here, and sodium chloride is said to possess a face-centered cubic lattice crystal structure. So the number of ions of, when you see oppositely charged that surrounds, give ions to give charge is known as the coordination number of that given ion. So how many of them, how many can coordinate form a phase? Because if you have seen the crystals of the salt, you will be able to understand its shape and how beautifully these are arranged together. So now sodium crystal and chlorine. The sodium and chlorine have formed a sodium crystal, and based upon the number of it happens. So now let us recall, generally elements of metals have a tendency of losing electrons to attain octet in the valence shell. So all the metals are generally, their property is called, the metallic characteristic is called as electropositivity. So elements with more electropositivity form cation. Aluminum is 3+. Okay. Similarly, non-metals like oxygen, fluorine, chlorine, they acquire to form an inert gases or gain electron. They try to gain electron. So these are and to form an octet rule or the inert gas rule by gaining electron. You can see that oxygen, and so this property of non-metallic character is called as electronegativity. As I told you, don't get confused. When it's losing, it will be positively charged, and if it is gaining, it's negatively charged. So now you can explain the reason for all this. Ionic bond is formed between atoms of elements with electronegativity and difference equal or greater than 1.9. Okay. So you have noticed that the atoms either lose electrons or going to attain the octet valence shell. So I'm sure that it's now very clear to you all. This is an ionic bond. That transfer of electrons takes place by combining atoms. You know, these sodium and chlorine atoms, they combine together. So the tendency of losing to form cations or gaining electrons to form anions depends upon the following factors. So what are the factors? So the factors that are responsible is atomic size, ionization potential, electronegativity, and low electron affinity, high atomic size, and low electronegativity from cations. So these are the properties of the elements that are responsible for gaining or sharing of electrons. So what is high ionization potential? What is high electron affinity? What is small atomic size and high electronegativity? Like helium is very small atom, but why is it so stable? So Lewis in 1916 proposed that atoms of some elements could achieve an octet in their valence shell without the transfer of electrons. They can attain octet configuration in their valence shells by sharing their valence electron with one or more atoms. As I told you, in sodium chloride, there is no need for them to lose or gain. They are sharing and forming a new compound or a crystal. So now coming back to this, each fluorine atom contributes one electron for bounding, and the electron core that is formed in this way is mutually shared by both the fluorine atoms. So you can just see that fluorine has got 1, 2, 3, 4, 5, 6, 7. So 7 electrons in its outermost shell. So if both these fluorines are combined together, then both of them are becoming stable, okay, forming a bound. So a bound can be represented like this or like this. Either way you can represent, showing that a bound. Either you can have two dots in between, or you can place a hash or a dash in between fluorines to show that they have formed a bond. So now if you look at oxygen atom, oxygen also has got 6 electrons in its outermost shell. So oxygen can again combine with another oxygen. We generally find oxygen in the form of O2. We don't write oxygen as O because it has got the highest tendency to attract its own atom and form a molecule. Like fluorine, oxygen, most of them, they have a tendency to form a covalent. This type of bond is called as a covalent bond. 2 oxygen atoms are there and 2 pair of electrons are shared between them. You can see that in oxygen, the electrons that are, whereas in fluorine, we have seen that it was having, the outermost shell was having only 1 electron in fluorine. So the bond that it has found was only a single bond. Whereas in oxygen, the outermost shell has got 6 electrons. So if oxygen had to combine with another oxygen, that means the covalent bond that is formed has to be formed between 4 electrons. So that is the reason it is called as the double bound. So you can see, you can represent it either this way or, you know, both the way. In the exams if it is asked, either you represent this bound. If you are representing it like this is also correct. Or if you represent it like this, even this is correct. You know, here you are showing that this is a good way I prefer, because you are even able to show that 4 electrons have been shared by this. And this is to show that there are diatomic, double bound. If there are 2 steps. Whereas in fluorine, you are only you have to write only 1 bound. Okay. Now going back. You can say that this double bond is formed in oxygen. And both oxygen atoms have octet in the valence. So both of them have attained the octet rule, right? Uh, Now coming back to, this is the most interesting, and every time use vitamin use. So CH4 molecule, we say that carbon has got 4 electrons in its, let's go back to see how the carbon and hydrogen bond is formed. Okay, so going on so quickly, like you see, carbon has got 4 electrons in its outermost shell, and whereas hydrogen has got only 1, right? So this, and if you see the H2O bond, water bond, oxygen has got, needs 2 electrons to form an octet group, whereas hydrogen has got 1, so it requires 6 electrons to form an octet group. So both the hydrogens combine with an oxygen to form a strong bond of water, where both the hydrogens as well as oxygen is forming an it's forming a molecule with octet rule and becoming stable. Similarly, carbon has got 4 electrons, so it can combine with 4 hydrogen, CH4, methane, to form a covalent bond. So you can see how this bond is formed. It is called as a covalent bond. So we see that 4 hydrogen atoms can. Now the formation of water molecule, as I've already told you, then again you can see how it is combining with each other. Oxygen requires 2 electrons, whereas hydrogen each one requires 6. So 1 hydrogen can share it with 2. 1 oxygen can share its electron with 2 hydrogens. And that's how this single covalent bond. We can see in water molecule H2O, there are 2O and 1H. H single covalent bond is formed. So with this, a bond like this is formed in water molecule. The water which we drink every day, we see water flowing from the taps, is nothing but hydrogen and oxygen. And through process of electrolysis, we can even separate and see these both gases. You know, these 2 gases, when they are combining together, they form a new molecule, new substance, and their state also changed from gaseous to liquid state. Okay, so it has completely changed its state. So electronic configuration of oxygen is 2, 6, and hydrogen is 1. So oxygen needs 2 electrons to attain octet in its valence shell, whereas hydrogen requires 7 electrons to share. So how is it getting those 7 electrons? It's electron plus 6 electrons from oxygen and another hydrogen atom. So that is how a covalency. They share the total number of covalent bonds that an atom can found is 1 second. So in this covalent, so you can see that the bound length or bound distance is the equilibrium distance between the nuclei of 2 atoms which form a covalent bond. You can see the 2 nuclei of these atoms which are forming this covalent bond. generally, given in nanometer or angstrom unit in length. So these are again, most of the time, these units are named after the scientists. So angstrom must have found it out. So we measure it in nanometers or angstroms, like liquids are measured in liquid, as you all know, liters or milliliters, whereas solids in grams, kgs. So similarly, we generally see that these are the units to measure our molecules. Molecules are always measured in nanometer and angstrometers. And 1 nanometer is equal to 10 minus 9 meters. When we are measuring anything in meters and milli, so 10 minus 9 is 1 nanometer. So bond energy or bond dissociation energy is the energy needed to break a covalent bond between two atoms or diatomic covalent compound in its gaseous stage. Isn't it? We have already done it in the earlier classes. There is an energy that has to be that electrolysis. We are using an electric energy to separate hydrogen and oxygen, and they are liberated in the form of gases. So a liquid can again be converted back. A molecule which is which is in the liquid state can again be converted back into the gaseous state through a strong energy, and that is called as the electrostatic force or electrolysis. The process is called as the electrolysis. So here, electronic theory of valency comes into picture. See what exactly is happening here. If you see hydrogen, when a covalent bond is formed between any two atoms, irrespective of the nature of the atoms, the bond length and the bond energies are expected to bet the same. Okay. So now I think for today, to understand, it has become clear for you all what is covalent bond and ionic bond. So please go through it, and let us have again an assessment test in my next class. Most probably I'm having it on Tuesday or Thursday. Whenever it is, please check your timetable. So we will be having a assessment test again and to move further. So till then, take care, go through it and try to understand. Wherever you're not understanding, message me, or we will be having our next assessment class where you note down all your doubts so that we can get it clarified. Take care.